Okay, so we are going to find a trick on how to actually change or convert absolute values into a piecewise function. So how do we do that? So I have two examples of which we should do. Graphing, I won't do it, but I'll give a hint on how to graph. Alright, so what you are going to do here is, it's a Friday test. By the way, I need to write test there. Okay, so it's a Friday test, and you will be able to solve tricks. We'll be able to find a trick on how we can actually solve very fast the same piecewise function, because defining require a lot of time, but I've found a trick for you guys. Okay, let's go. Okay, so I have two equations here with me. So what you need to know is that these are absolute values that you can see. These are absolute values. These. Okay, so these are absolute value. So what is an absolute value? So an absolute value, it's just a value, all right, on a number line. Suppose I tell you to say, oh, find the value of let's say this is 0. Okay, so the distance, let's say here it's 10, and also here it's 10. Okay, so the distance from here to there, okay, and also the distance from here to there is what we call absolute value. So it's on the number line. So if I say it's 10, so it's on the number line. Probably you also need to have -10 there, you get. So that's the reason why you have been giving in two forms, positive and negative, meaning that absolute value should be giving you two values. So now how do we achieve the issue of converting now the same thing? So the picture here is, we just need to show them to say we are able to actually show that yes, the function will be represented in the form of positive or negative. That's our duty. Okay. Okay, so now what you are going to do here is, we are going to say want to actually change. I said we can have negative or positive, right? So now this function here, a, all right, what I'm going to do here, I have the function, okay, x minus 5, like that. So what I'm going to do here, for me to redefine, it should be in the form of f of x, all right, then is equal to, I'm redefining this function, all right. So I need to have, I can have sometimes three things here, okay, but for this case it's just one modulus, so meaning that I'll have only two things. So I'll have a situation whereby x, okay, minus 5, okay, it's positive, all right. So if it is on a curve like that, okay, all right, so you need to solve what is inside there. So pretend you are solving that what is inside, so that will be x minus 5, then is equals to 0. So meaning that x is equals to what? 5. So here we have 5, right? So we can have whereby x, okay, this is the range of 5, okay, it can be this side or this side, just like we said, to say absolute can be this side or this side, okay. So depends, right? So absolute need to give you two values, left or right. So now in a situation whereby we have now on the left, then x will be less than, you get, because all the values of the here x is equals to 5. So now if we come this side, x will be less than that value. Okay, so that is it. Then again, if we go this side, x, okay, we'll start at this point. So in short, I can say x here is greater than, let me write like this, x is greater than, okay. So you also include 5, because we said x is equals to 5, so it includes 5 like that. So it goes like that, you get. So that's how now we'll be displaying this. So now you solve the equation. Now for this case, that's given us 5. So say x, okay, at this point we won't have this going this side or going this side, all right. We can go this side, of which since x is start at 5, now all the numbers that we'll be getting from this side, they will be less than 5. So I would like to say x is less than 5. Okay, I can start like this, or if I want I can start like this by saying x is equal or greater than 5. You get? So I'm starting because of the way I'm displaying the number line. I start from this side, then from negative, then I'll go to positive. That's what I'll do it. So you choose whether you start from here, but I advise you to start from negative, then you go to positive. Okay, so that is it. So now what you are going to do is, we know that this is just x, all right? So meaning that it can be negative or positive. So this side I'll say it's positive, all right? So absolute value of, let's say, x, this x can be negative. Okay, you can multiply times negative, so it's plus or minus. You can multiply it with negative, it can be negative x. This is now where you get the less. Then again, it can be positive. This is where you get what? The greater. This is the less. So here I'm putting a positive. Then here we have again x minus 5. All right, so now what I'll do, this is the condition, by the way, it's less than this side. So let me do this. Get me clear. So if I say this side, I'm starting, this is the boundary that I have. Okay, here x is negative. Okay, it's like someone is getting confused there. We want to redefine this function. So how do we redefine this function? We'll redefine it by saying on a number line there. Okay, we'll solve what is inside there. We'll say x minus 5 is equals to 0, meaning that x is equal to 5. Okay, that's what you do, first step. Then if you check on a number line, it's here, right? These are the value. We only have one value of x, so we can have values going this side and also going this side. By the way, this is 5x. Then what we'll do is that we are going to say this side, my x will be less than. Then this side, since I'm now increasing, is giving the positive vibe. So what I'll do, I'll say this side x is greater than 5, or it can be also equal to 5 because it will touch this 5. It will start at 5, so it's starting at 5. So that's why I'm putting this equal to. Okay, so what I'm going to do, this is the case of, now I want to start from the left, meaning that from my negative. So I'll put a negative there. Okay, then I'll say x, I've just moved the modulus, then x here, okay, is less than 5. Good. Then again, if I come there, all right, I'll say here is now positive. Okay, then I'll say x is minus 5, like that. Then x here it's at this point now, all right, going this side. So I'll say x is greater than or equal to, it can start at 5 going that side to the positive. So this is the thing here. So you can see now I can distribute this negative inside there. Then we'll be ready to go and redefine the modulus. Okay, so meaning that our next stage now, say f of x, okay, is equal to, all right, so I'll say this is now negative x plus 5. Okay, then here I have, it's just the way, because positive and positive, that will be just x minus 5, like that. So there's no change here, it's positive minus 5, like that. Then x here is greater than 5 or equal to, then x here is less than 5. So this is how you have redefined this modulus function. So if it's about to plot, you get this one which is here, and also which one, this one which is here, the one you have redefined. So you can plot by saying, now plotting, that should be your job. Okay, so this is how I've redefined the function. So suppose now I want to plot it, I'll say, okay, so I'll plot this, let's say I'll write the Cartesian plane there. Okay, so what I'm going to do here is, x is at 5, by the way, starting at 5, we saw x is, it was giving what? 5, right? So x is 5, so say x is equal to 5. So now what you are going to do is, at x, I can just imagine to say x is 5 here. Okay, since x is 5 here, for the first one, which is less than, it is going this side, right? It is going this side. So what I'm going to do is I'll get any number, all right? Because the range is for this graph whereby 5 here, x is equals to 5. Then I can test the numbers that are just this side and also numbers that are this side. So if I choose the number that is on this side, it will be, so 5 of this side, it will be, I can choose -4. All right. So if I put, I can put even 4, just 4. It is less than that. So if I put 4 here, right, I'll get positive what? I'll get positive. If I put 4 here, I'll get positive 1. So, but before that, I need to choose the numbers. This is 5, right? So this is 5 here. So I can go, all right? So this is 5. I can choose any point that is at 5. So I can choose 0. Okay. 0 is also less than 5. Because this is where it is saying that should be your initial point, right? You don't have to start anywhere. That should be your initial point. Though at this point it will be open because it's not, this thing is not there. All right. So I'll say x at this point will be there, right? Now it will be open like that. Okay, like that. Then it's open because it's less than. Okay, it's not equal to, less than or equal to, so it's open like that. So now I'll get another point. So I use the 0 now. I use the x is equals to 5, right? So if I put x is equals to 5 there, that would be 0, right? I've put 0. Then I've started at the same, you start with the same point you have there. Then I can go now to 4. If I put 4 there, x will be what? So it will be 4 comma, what will be your y? So if you put 4 there, that y will be 1. So here, then y will be there. Okay. Then again, if I put, let's say 3, if I put 3 there, I substitute 3 there, that will be negative. That will be just 2. So it will be, I'm putting 3 there, then again it's giving me, you have seen the way it is moving. It is moving like that. It is moving like this. Okay. So that is the way to be moving. So it goes like that. Okay. Then what if now we have, for this situation now where it is starting, okay, so I'll put that what is inside there is starting. So I'll put for the positive one, meaning that is starting, okay, it's not less than. So I'll start the same 0 there. Okay, I'll put the same 5 there. If I put 5 here, I'll start at 0, right? I've started at 0. Then again, if I go now, what number is greater than is this side? Okay, I can put 6 there. If I put 6 there, you'll see that 6, if I put 6 here, then 6, substituting 6 there, minus 5, that would be 1. All right, so 6 here then is equals to 1. All right. Then again, if I put 7, let's say 7 there. Okay, so if I put 7 there, then that would be, you just need 2 points so that you see the way to be moving. So if you put 7 there, then that would be 2. So 7 at this point, then it will be 2 like that. Okay, so we have seen that the value now will be it will be moving like this. So it started with what is inside, right? So what is inside there, it is like that. Okay, hope that is clear. So this thing is dotted inside there, is dotted. For the one which is going this side, is dotted. So that's, have you seen the reason now? It's running away from the negative. That's the meaning of absolute value. So this is it was just a polynomial whereby it's giving the domain, the range, as all the positive. Like it's going this side, it's going this side, and also going this side. So the domain will be okay, will be 5, negative infinity first going this side, then comma 5, then union again the same 5. Okay, 5 again. This point I can even close if I want, like that, because it's closed for this one which is going this side. So that will be now then positive infinity. Okay, so this will be my domain. So that's about this modulus function into piecewise function, and also graphing at the same time. So we have done this. So that's how you should be doing this. So let's go now to a last one. Okay, so be very fast. Now this is where I need you to pay attention. Okay, so you have seen this again. At this point we are going to have a region where, okay, so what you do first, you solve these individually. So say x minus 5, okay, then here have x plus 3. This one you start to say is equals to 0, even this one is equals to 0. Here I'll say x is equal to 5, right? Then here x is equal to negative 3, like that. It always give a negative and positive for such a case. So what you do is you start with a negative, right? Negative 3 there, then we have a positive 5. So you can choose how to present these signs. At this point, going this side, I'll say x, okay, this we have region A, region B, region C. So going this side, we have x is less than negative 3. If I want, I can put equal, but that would depend with what I'll write again in between here. So at this point between here, all right, this point, so here x, but I don't start with x, just I would like to say negative 3, okay, is less than or equal to the same x. Again, the same x here I have, okay, so this x here, all right, let me write like this, I'll say the same x here, all right, it can be like that. So here at this point here, it can be less than or equal to, again it can be greater than negative 3, again equal to the same 5 here. Have you seen the way it is moving here? This just within this region, all right, x can be equal to the same 3, and again can attach, again it can be less than, you get. So then at this region now, C, region C will state to say x now this point will be just, it can be 5, you connect the same 5, right? So here it was touching, so here I'll just say 5 is less than x, because at this point it was touching, then at this point it is being touched by this symbol and also this symbol. So there's no need of, you just have to know the way you are connecting between, they need to be attached. Then on the left they need to be less than, more like without even equal to, even this side they need to be greater than 5 even without equal sign. So you need to know that range. So hope that is clear. This is how we'll be finding the region. So now if we have understood that, so let's go and now graph this, I mean redefine this by saying f of x, okay, will be given by, all right, okay, so we have seen that x, okay, so this is how you test. We have negative 3, we have 5 there, okay. So what I'm going to do is I'll get this graph, so you go with the signs, okay, try, I want to charge it, so this is step now, you charge the signs, so charge with signs, okay, charge with signs, or just charge the functions. Okay, how do we charge them now? You are putting the negative, so you test. Let's say here you get negative 4, you put negative 4 here for this one, that will give you what? If you put negative 4 there inside, okay, that will give you what? That will be negative 9. So in short it's giving negative, so I'll say negative, open bracket, it's giving negative, that's a product, so I'm putting the product there, then that will be x minus 5, okay, then plus, okay, before I even write this plus, I will know first the sign. I don't mind about this negative, but it's there. So okay, let me do this again. Let me do this. So then I want to charge this as well. If I put again the number which is less than negative 3, that would be negative 4. If I put there, it will be a negative, so that would be negative, right? So I'll say x plus 3. Okay, hope that is clear. I'm just doing it after this, then I'll be done. So again, between there, all right, between again, so this was the condition whereby x is less than 3. So I'll say x is less than negative 3. Then at this point again here, where x will be in between this, okay, so that point we are saying x is negative 3, okay, then less than or equal to the same x. Again, x can be less than, we are just trying to attach or make a bridge. That's the meaning there. Okay, so I've decided to attach like this. I will attach them, then the rest I'll be just leaving them open. So that's how you do. You choose. Don't get confused about these signs. You choose the way. You just have to know the way they are connected. Sometimes you can say this will be less than this one. Then if I say this is less than, then this side was supposed to be equal to this side. So but I'm not into that. Okay, so I've decided to use this path whereby in the middle there I'll put like that connection. So you choose. So since I've put this as the boundary between the bridge, so now again I'm charging. Okay, so between there's a number between there. Okay, what number can I choose? Is negative 3. I can choose even 0. All right, so if I say 0, if you put 0 there, okay, 0 there, then that will be negative. So I'm charging with the negative. So that will be x minus 5. Okay, then plus again, open bracket, I want to see the charge that will come there. If I put again 0 inside there, that will be positive. So it will be just the positive. Okay, right? X plus 3. Okay, so from there, then what I'm going to do is the last one, the last region. Since I said here is less than, then here I'll say x is, all right, so I'll say x here, it will be greater than 5. That's how I've decided to present them. The bridge that I've formed, it doesn't allow again to include equal to, because I've already included equal to there. Again, the bridge that I've formed, it doesn't allow to include 3 because I've left 3 in the first place. Then I have to include it. Again, 5 I've included this point. Then I have to leave it. That's you need to understand the bridge. So now what I'm going to do, I'm charging now. So these are numbers that are greater than. So we can test the 6. So if I put 6 there, that will be what? Positive. So that will be just positive, open bracket, x minus 5. Okay, then hope that is clear. Then there's that plus. Again, I'm charging. So if I put there again, I put 6 there. All right, so 6 there, that will be again positive, right? So that will be just the same thing. So that will be positive, then x plus 3. So that's how I'm like, it's just as simple as that. Than you getting one function you define into main. No, you just use this trick. All right, so now the final now will be f of x. Okay, so now this point you multiply their negative times negative. Let me just solve them independent. So I'll say I'll be solving them. I get 1, then I'm just simplifying, by the way. So simplifying this that would be a negative, this into negative that would be negative x, then again negative times that would be plus 5. Okay, then here it's just negative, right? Negative inside, so this negative will be reduced. So we'll say plus negative times that would be negative x. So that would be negative x, then that would be negative 3. Okay, so that would be now negative x plus 5, then negative x, negative 3. So here x will be negative 2x, then this plus that will be plus 2. So the function that is supposed to be it is x negative 2x plus 2 like that. Then the range is x should be less than. That's how we have been coming out. So say x is less than negative 3. So that's how you have defined that function. So again, let's go to the mid part. So the mid part, it will be this one, you multiply times that will be negative x, then that will be plus 5, then that will be now plus, these are just positive, so x plus 3. So that plus that, 6 plus that is 8, so it will be negative x, 5 plus 3, that will be 8. So this is the function that you have. So you say negative x, then plus 8, you are done. Then again, you come at this point, you say this is just positive, right? So that will be x minus, this is minus 5 by the way, then also this is positive, so they are all positive for this one. Okay, so they are all positive. So how do we now present them? This, I'm talking about this one. All right, so it will be x minus 5, they are all positive, so that will be now just plus x, then plus 3. So meaning that this is now x, it will be 2x. All right, then that will be minus 2, because 5 minus that is minus 2, then x plus that is plus 2. So you light, by the way, for this one I'm supposed to light the linkage here. The one I have there is negative 3 should be greater than or equal to x. Just understand the way you are connecting. Sometimes I can say less than, then in the next place I'll say 5 is greater than. So but I'll just leave it because I've included at this point and also at this point. That's the reason I've put negative and that like that. So here we found to say 2x minus 2. So this is now you have redefined this function. So this is now a piecewise function. So hope that is clear. Then now how do we graph? Let me just teach you how to graph in the next 4 minutes. We'll see how we can graph. So how do we graph this? So away from all these, so you charge the function. Okay, so don't forget that rule. So how do we now allow me to write it properly here? So f of x is equal to, okay, so I have negative 2x plus 2, then I have negative x plus 8, then I have 2x minus 2. All right, then here the range is x should be greater than 5. Then here x is negative 3 is less than or equal to x. Again, the same x is less than or equal to 5. Then here the condition was x is less than negative 3. So now how do we graph this? Okay, so graphing this function will say, okay, so suppose I have the Cartesian plane there. Okay, so I'll say this is a Cartesian plane that I have. Okay, okay, so this is my Cartesian plane. Now just assume small numbers. Okay, so then what I'll do is I'll say I'm graphing this, so I can start at negative 3 there. All right, so x, let's say, is negative 3 there. All right, then what else? Again, x, I can just choose those numbers which are sensitive. Then I can say x is now also 5. Okay, so what is the next thing then I need to do? I need to say I'll start now for this one. Okay, it is starting at x, now x at 3. All right, now at 3, it's starting at 3 by the way, but it will have a round because it's not equal to. Okay, so I've started there. Then I can choose numbers that are less than the same negative 3. So I can choose, I can put, so remember the graph was, we have negative 3 and 5 there. Okay, so numbers that are this side, we can have negative 2. So if I put negative 2 there, negative 2 there, it will be negative, you put negative 2 there in this one, that will be negative 2 okay, negative 2 again plus 2. So that will be now negative 4 plus 2, which will give me negative 2. Alright, so if I put negative 2 at this point, no, I'm not supposed to put negative 2. I need to put numbers that are going this side. It's negative 4, like that. So negative 4 is this, and negative 2 is greater than, so I made a mistake there. So can we plug in negative 2, negative 4 I mean. So if you put negative 4 there, that will be positive, right? So it will be 6. So if I put somewhere there negative 4, then that will be positive 6, meaning that 6 is somewhere there. Have you seen? So these are enough, these 2 points are enough. So I can even now graph by saying it's open, so it's starting like that. Okay, so that's how it will be moving. So that's how it will be moving. So it goes like that, okay, because it's starting at that point. Okay, so from there, then what am I going to do then? What am I going to do? So what if anyway the limits has reached the duration now is 30 minutes, so I won't proceed. So what I need to do for this one, you solve this one first. You say negative 2x plus 2. That will give you what? When you solve this one, okay, it will give you what? It will give you negative 2x is equals to negative 2. Okay, suppose there's a 0 there. Then that will be now x is equals to negative, no, that will be just positive 2 there. All right, so graphing, let not graphing be the part of this session, but just redefining. I'll waste a lot of time, just small things. So graphing will be something else. You know how to graph, I'm sure. So let's just end here because of time. Okay, so let us just learn how to redefine. The graphing is not a problem because you know you have this equation and the range you have there. So you just solve this equation. You know the starting point and the boundary is there. So meaning that you are less than that. Okay, so that is it, that you should be like things that you need to know when graphing. So you know to say this is the equation that have the boundary is this. So you need to start at negative 3, then you solve this one. Okay, when you solve this one, you say you solve at this point, like you say solving this one, it would be negative 2x, then that would be just negative 2. Then when you divide that, x is equals to 1. All right, so what you do is you are starting at 1, so you start with the same thing. If you want the same negative 3, just to start that point, but x is equals to 1. So you go where x is equals to 1, and you'll be able to see. In short, let us just know to say that's how we should really define the function. Let me not confuse you. You know how to graph. Each and everyone has a trick of graphing, so let me not disturb your trick. You are about to write an exam. Otherwise, thank you very much for actually paying attention on how to easily hack the way of defining these modulus functions. Okay, so that is it. Thank you very much.